Hello. Today we're going to talk about reference materials, certified reference materials, and quality control materials. We'll speak a little bit about the differences in their uses. The reason that this topic was chosen is it seems to be a ongoing issue throughout the community when being assessed to 17025. It's important to understand the use of the right reference material because only certain reference materials really do provide that metrologic traceability, even though the materials themselves may be comparable. Barry Johnson Lab Accreditation is a cross-sector accreditation body recognized in the areas of testing, calibration, and medical laboratories, inspection bodies, reference material producers, and PT providers. We also work in various government and industry schemes. So to start this discussion about reference materials, testing is really a comparison of an unknown to a known. That something known is a reference material. That term reference material really is a very generic term. The quality of the data is really only as good as the reference material used to calibrate the measurement device. And there's using accredited sources, you have high quality reference materials available, and they're attested to having both the technical processes to create and certify the material, as well as the appropriate management system. As I said, reference materials are used to support measurements. Measurements can include for chemical composition, it could be biological, microbiological, clinical, physical, and engineering properties. They have reference materials have many different forms, and we'll talk a little bit about their different types of uses and which ones can apply to certain uses throughout this discussion. So in a general term, what is a reference material? And if you do a web search, you'll see reference materials, quality control materials, QC, standards, CRMs, and it really does get confusing. So I'm going to stick with the definitions found in ISO Guide 30, which relates back to reference material production for ISO 17034. So a reference material is a material that's sufficiently homogeneous and stable with respect to one or more specified property values. These have been established to be fit for its intended use in a measurement process. A certified reference material is one step further. It can be the same material, but it would go through additional testing. So a certified reference material is a reference material categorized by a metrologically valid procedure for one or more of those specified properties, accompanied by a reference material certificate that provides the value of the specified properties, as well as the associated uncertainty and a statement of metrologic traceability. Reference materials for analytical chemistry are designed for one or several properties. You may have a pure chemical or you may have a mix. In addition, you'll also see that depending on what type of material, they may be in bulk form, or you may have a small aliquot ready for use. So let's talk a little bit about the forms of reference materials to give you some understanding of what's really intended and what's important about the reference materials. So the first one is pure substances. These are characterized by chemical purity and other properties such as melting point, viscosity. A pure substance, when it's a certified pure substance, has gone through testing not just to identify the substance itself, but it's also determining the pure value. What's that level of purity of the substance? So in the case of, let's say we're doing an organic solution and we're creating a neat material. Well, this neat material would probably not only have been tested for comparison to make sure the identity is correct, the reference material producer is probably going to look for impurities. They may look for water and do a Carl Fisher titration analysis. They may also do additional testing to see how much inorganic substance can be found by doing a residue on drying or a loss on ignition, depending on how you want to term the test. So these are substances that are typically, it's one substance um, characterized for that purity. Next one is standard solutions or gas mixtures. These are often prepared gravimetrically as from those pure substances. So that initial property is already established. We know what the purity is. We know how to create a standard at a certain concentration. And so it gets built upon from there. Matrix reference materials are a little bit different. The first two that we spoke about are prepared pretty much in the current state, where matrix reference materials themselves are characterized from a composition of selected properties, such as the content of the chemicals. It could be the minerals found in a rock. These are normally prepared from naturally occurring materials. And that's one of the bigger differences is the certification process becomes much different, where for something like a pure substance or a standard solution or a gas, the certification itself may be injection of multiple aliquots from the production batch to establish that value. A matrix reference material typically goes to multiple laboratories and sometimes around the world to test for the levels of the specified values that they're looking for. And then they report, those testing laboratories report back to the reference material producer the values, which then get put together to determine the quote unquote true value of that reference material. Physical chemistry or physical chemical reference materials are characterized by items such as melting point, viscosity, octane number. And then the last category is reference objects and artifacts. These are categorized by a functional property such as taste, odor. This type of reference material also includes specimens characterized from properties ranging from the fiber type to microbiological specimens. So there's a variety of forms of reference materials. And then to understand them a little bit further, we'll talk now about their hierarchy, and we'll start to build in for the uses of the materials themselves. So before I get directly into this slide, I'd like to take a minute and really discuss metrological qualification in a broader sense. So we understand that for chemistry, reference materials are that main building block of the traceability chain. And my focus is going to be around chemistry because that is the bulk of reference materials available in the marketplace. So it's important to understand their metrological characteristics. Does it have an uncertainty supplied with the property value? If so, it puts it into a certain category, which is a certified reference material. And it provides that push into the traceability hierarchy. Whereas a reference material that does not have a stated uncertainty, there is no metrological traceability. So that's something that I'll be going over time and time again in this discussion because of the importance. So in that broader sense, in physical metrology, measurement standards are classified according to levels of a hierarchy. There's primary standards of a measurement, the SI, the top level with respect to the quality and the identity. The second level would be those that are derived or verified from direct comparison of one or several primary standards, and so on and so on and so on. So NIST will have their primary standards compared to the SI standards found with the BIPM. When they bring those standards back, those will then be compared to other standards, which get then either to 17025 accredited calibration providers or states, weights, and measures. And we create this chain of this unbroken chain of comparisons. And each piece of that chain, you grow uncertainty. So you have these highest level items found with the BIPM. We have high level found with National Metrology Institutes such as NIST. And then they're still usable materials. They're still of good value, but there's greater levels of uncertainty because of the chain of comparisons. In analytical chemistry, an analogous system is limited. There's not direct comparison. This has to do with the simple fact that with analytical standards, you're subsampling your material. It might go through some sort of sample pretreatment, and then you would have to compare as opposed to physical standards where you have two gauge blocks. One can be directly compared to the other, and then so on and so on. So in analytical chemistry, the uncertainty is associated with the traceability links is often wider. And that's because you can't really do these long traceability chains. They're just ineffective. What's accepted is the use of National Metrology Institute standards, which go through a full certification process. These are certified reference materials. They may or may not be from accredited providers. NIST does not need accreditation, but they have that higher level of standard that they're creating from multiple testing components to really provide that characterization. The next part of that chain is the certified reference material. These are from 17034 accredited providers, and they're also accompanied, the top two, the NMI standards and the CRMs, are accompanied by a certificate. And those certificates, because it identifies the property value, the uncertainty, and a statement of the traceability, that meets the requirements for metrological traceability. From top to bottom, the least level of uncertainty would be with the National Metrology Institute standards, while the quality control materials will have the greatest level of uncertainty, or at least the uncertainty is unknown. If we look at the reference materials, and this is where it can start to get confusing, because everything we're talking about is a reference material. But if we go back to that initial definition, it's the general term, but there are lots of general reference materials out in the industry. And what also adds to the confusion is that they can come from both accredited providers, again, accredited to 17034, or competent producers. And here you need to develop and determine what is competent to create it for fitness for your intended use. So that right there starts that little bit of confusion. Well, this diagram, though, really does provide, from an accreditation aspect, the two things we would look for during an assessment would be either the use of NMI standards or certified reference materials. If those are available, reference materials aren't traceable. They may be used for certain things, and I'll get to that in a few minutes. And then the last one is QC materials. This is a very special category that we'll talk about, because in certain industries, these sometimes are the most applicable to use on a daily basis. So again, National Metrology Institute primary standards come from, an organization that is either the National Metrology Institute or a delegated authority to do that type of work. And here, the National Metrology Institute is NIST. You can get an SRM. It's a high-level CRM. So we'll go a little bit more into what we look at in certificates in a few minutes, but first, top level is always the National Metrology Institute. Reference materials, as I said, they're materials whose property values are sufficiently homogeneous and established. You need to determine the fitness for intended use. The providers may again be accredited or not. And when we look at that, it's about what is the need for this reference material? What is its eventual use? Reference materials themselves most likely do not have a stated uncertainty. So let's talk a little bit about the difference between accredited and a not accredited provider of reference materials, because you see that in the marketplace daily. If there's no reference to 17034, it's not accredited. But doesn't mean that it's not a useful reference material. So a competent producer of reference materials, as well as the reference material producers that are accredited, probably look at the purity of their raw materials and to get an understanding to create the solution, to create the product as defined. And that's that characterization. But there's not really a true statement of uncertainty. It's not a full characterization around that product. So reference materials, general terms available. Features, property value, it may be assigned just through the materials preparation. I know I have 1,000 ppm of this solution. I need to create a 10 ppm solution. I do a volume to volume preparation. Here you go. That's your property value because it's the prepared to value. Reference materials, you would receive a product information sheet. Again, it's available from an accredited 17034 provider or a competent producer. A couple of things to remember, and this is really important in terms of the accreditation scheme as a 17025 lab. This may or may not be tested. It's the property value is what it is, and it can be assigned through preparation. It's not really a certified value, just the property value. There's no uncertainty statement, and therefore there's no metrological traceability. Certified reference materials. This is the big one. This is the one that you'll see most often. This is the one that your assessor would expect to see utilized in the laboratory. It's characterized by metrologically valid procedures. And you see that wasn't part of the general term reference material. So that metrologically valid procedure is meaningful here. It has metrologic traceability because there's an associated uncertainty to those certified property values. And these will always come from accredited producers. So I'm going to speak a little bit about the other category, which is quality control materials. And these really are uncharacterized reference materials. There's no property value that is through any certification process. The focus is on the preparation of the material. And then most of the time, a laboratory will test it. And then the last one is the laboratory itself will define the fitness for purpose. So with the quality control material, it's created by the laboratory for its own internal use. There's no accreditation. Well, why would this be done? What's the use of a quality control material if it doesn't have a formally assigned property value or an uncertainty? Well, you have to look at unique markets, or you have to look at markets that may have challenges. And I'll use currently the cannabis market in the US. There's a federal prohibition to ship it over state lines, cannabis, and especially the active THCs. Because of the prohibition, your reference standards are very low level. You're nowhere near the percentage levels found in plant material. So As a cannabis testing lab, how do you really determine your control? Probably best to make your own quality control materials with cannabis that you can purchase within your state, grind, or create an oil or a tincture out of it as a control sample, as a measure of your process control. So quality control materials have value in certain marketplaces where other markets, it may not be worth the push. Often, quality control materials are prepared in the laboratory from stock chemicals, either a weight to volume preparation or a volume to volume preparation. These are prepared from, or they can also be prepared from in-house materials. You need something in matrix, you have it available. You create a standard from it. A lot of people do that with old proficiency tests. They use it as a quality control material. There's no certified value in most cases outside of a PT. We can make an argument for or against. There's no uncertainty statement, and there's no metrological traceability of a typical QCM. But again, they're very useful for certain applications. So to summarize the types, while the term reference material is a general term and it's used throughout the industry, there could be you have National Metrology Institute standards, you have certified reference materials, and these are both the top level materials. They're the most categorized with the least uncertainty around the assigned values for those properties. Going downstream, we have reference materials. These come from either accredited producers or competent producers. And then we have QCMs, which are the in-house materials. When you look at the reference materials themselves as a category and the QCMs, these are the least categorized and they have the greatest uncertainty. Okay, so what does all this mean? Well, there's information available, and this is where we start to build into that accreditation aspect. There's a lot that goes into a certified reference material, be it from a National Metrology Institute or an accredited provider. They're looking at, well, first they're assessing their raw material to determine the purity. The information that's available to you on a certificate would be the identity of the item, the content. There's an assessment of the homogeneity and the stability of the product, the associated uncertainty with the characterized property, as well as the contributions of the homogeneity and stability. And because of that uncertainty, along with the content and identity, we have completed a metrological traceability chain. So to the right, if you see reference materials and quality control materials, you have identities, you have content for reference materials, but, and this could be a big but, because the content, depending on if you're using a meat or a salt, unless that content was determined by an accredited lab, that 99% pure value, you can take it with a grain of salt. So that becomes part of the challenge when you're not looking at it from an accredited standpoint. So it's less rigor involved in the process. There's no assessment for either any of these of homogeneity, stability, uncertainty, and because there's no uncertainty, there's no traceability. So why do I say maybe but for QCMs? Well, you might be preparing to a value, but again, without really doing a whole study and understanding the content, there's probably going to be that greater uncertainty. So the content, the characterized value, it's what you say it is, not necessarily through a rigorous testing process. Let's talk a minute about what is really important when you look at a certified reference material certificate. And this is a big one. This is one that constantly I see in laboratories for 17025. I look at a reference material certificate, I go, that's not a certified reference material. So what you want to do is educate yourself on what's really needed on a certificate to make sure you have a certified reference material, because there's many things in the marketplace that say it's certified or certificate of analysis. Doesn't mean that it's coming from an accredited source. So what you want to look at is there a certified value? Is there a statement of uncertainty for that certified value? Is there a statement about the metrological traceability of the product? Is it on a certificate? And do you see the symbol of the accreditation body or a reference to 17034 accreditation? Those are the important aspects. And I keep talking about 17034, but depending on how long a product has an expiry date, you're going to also see accreditation to ISO Guide 34, which was the old equivalent to 17034. And it was just bumped up to a full standard instead of a guide. So these are the things you really want to look for when you purchase a product and intend to have it meet the traceability requirements for 17025. Okay, great. What does it really mean? Okay, so this morning I just pulled out an EPA method, EPA 200.8. And section 7.3 says that standard stock solutions can be purchased from reputable commercial sources or prepared. Now the method gives you a choice, or prepared from ultra high purity grade chemicals or metals. And then it has a whole list of the recipe, so to speak, on how to do this for each analyte in the suite of tests. So this, for federal testing without accreditation, you can do either and you don't have a problem in terms of traceability, because they're not looking at it from metrological traceability. Now, you can prepare it from the alloy. In the accreditation world, that's still just the QCM. You can purchase a reference material from an unaccredited source from a supplier. Or you can purchase that CRM that has data behind it to identify those aspects of the homogeneity and traceability. So these are the three levels. From 17025 aspect, we would be looking for a CRM. Now, but this is all the same. You can hear somebody say it now. If I created it from a pure metal, why can't we use that? It's the lack of the understanding of the uncertainty around that preparation. Now, if you did a full characterization study and you can demonstrate that and you did a comparison, eventually it's going to go back to be compared to something higher on the traceability chain, such as a CRM or an NMI material. If you have all that together, you can probably make an argument that that is metrologically traceable. But you'd have to have all the data to back that up, including those assessments of homogeneity and stability. So a lot of times it's just easier, quicker, and cheaper to purchase the CRM. So the general reference materials and quality control materials, why even bother them? Well, there's certain things that these are good for because they're sometimes lower cost and you can just prepare them yourselves. So reference materials and quality control materials have 4 real items that you can use them in your laboratory. It could be for method development or method optimization. It can be for understanding your quality control, your process control. You can use those. Obviously, you can use those for training and for analyst confidence. Where for NMI or CRM uses, you can additionally use CRMs for calibration, equipment qualification, establishing traceability, method validation and verification. And again, right, method validation always requires some sort of understanding of the measurement of certainty, that estimation of bias. So you really need to have a well-characterized material with its own stated uncertainty. You can use a CRM to assess the accuracy of your reference materials or quality control materials. So you're still moving that traceability chain, but you just don't have the aspect of uncertainty of your lower level reference materials. And then additionally, CRMs can be used for all the uses of reference materials. Sometimes you don't want to use a costly product for training purposes if you can get away with a much cheaper product or in-house material prepared preparation. So in summary, you have both National Metrology Institute standards and CRMs. They have a certificate. There's at least one property that's characterized. There's associated uncertainty to that characterization. There's a statement of metrological traceability. These can be used for a 17025 lab establishing their traceability chain. They can be used for calibration, method validation or verification, equipment qualification, or assessing reference materials in QCMs. Reference materials are the general term. They're determined to be homogeneous and fit for the intended use. They'll have a product information sheet associated to them if they're coming from an accredited provider. You might get information from an unaccredited provider, but it's not an official product information sheet in terms of 17034. QCMs are lab prepared, and again, you're determining the fitness for the intended use. Both the RMs and QCMs can be used for method development or optimization, process control, training, and competence. So I hope this short discussion gave you an idea of the differences of reference materials, what goes into the differences between reference material types, as well as the uses or appropriate uses in the accreditation scheme around the different types of reference materials. Do we have any questions?
Looks like we do have a couple. I will read one off for you here. So the first one is it strictly necessary to source reference materials from accredited suppliers, or is it acceptable to source from competent providers?
So we'll go back and think about that hierarchy from an accreditation aspect. If there's either a National Metrology Institute standard or a certified reference material available, we're going to look for those. But it's within your own quality system. What is the intended use? If it's for traceability, you need that. But if it's just process control and you're running a control sample with each batch, that can come from anywhere. So you really have to understand what the use of the material is. Remember that fitness for purpose, fit for intended use, is very important in the scheme of reference materials. Next question.
Okay, we've also got, if you have an accredited provider analyze a matrix, example mineral or rock, would the matrix status change as to RM or CRM?
Only if the accredited provider did a full assessment. And I think this would be a challenge because they would have to do a full assessment of the batch, quote unquote, of material. So a typical strategy would be you do an assessment post packaging, and then you would choose anywhere from 10 to 20 samples plus, depending on the size of the batch, of those to test. So it gets costly, first of all. So the answer is maybe, but they would have to test the material and determine its homogeneity, the contributions of uncertainty from homogeneity, and have some sort of evaluation of the stability of the product. And they would have to issue a certificate. You can have an in-house material that gets certified, but there's a lot that would go into it. It's not just, oops, they tested it in their lab, because at that point it could be just a 17025 certificate. Another question?
Sure, we've got another one here. Would you know where to source reference materials for verifying thermocouples?
Not off the top of my head, but the next slide will have my email. If you want to send me an email, I can try to find something, and I'll respond either way if I find something or not.
Okay, we've got another one. Should a QC material be a matrix? Can fortified method blank be used as a QC sample?
Okay, so we'll go back to that statement, fit for intended purpose. In the US, the answer is, yeah, that's fine. In the international community, however, a lot of times they're really looking for matrix matching, because, and here's the dirty little secret about some of these EPA methods. I'll use this as an example. You have, I've seen plenty of PT data for environmental laboratories over the years. The gravimetric value is typically a third higher than the assigned value. And that's because there's loss in the matrix of that in the matrix. So the prep is not, for instance, in metals, is not a robust digestion that you're going to chelate all the metals. So it's not as robust as other techniques. So some of that stays behind. With that being said, that's why it's better to matrix match, because you really can compare apples to apples, where sometimes you have to do a synthetic approach. And again, it's about cost effectiveness and determining that you need to determine what is fit for intended use for your laboratory. Any other questions?
I've got two more here. So is an ASTM standard considered a CRM?
So a lot of times, okay, so an ASTM standard being utilized for an ASTM method, it's probably going to be considered a CRM. And the reason I'm saying that is there's always an exception to the rule, and ASTM methods typically have you're building your traceability chain also to the method. So most of the time you can say and establish that. I am not sure off the top of my head if they are accredited. I'd have to look that one up. Another question?
Okay, last one we've got is what about primary and secondary RM?
So, oh, and this is where there's plenty of terms out there. A primary reference material would have to be one, a true primary reference material is coming from a National Metrology Institute. A secondary would be just a general term for, again, reference materials. And this is where that the market, sometimes there's a lot of clever marketing that goes on in this industry. I, depending on the application, a primary reference material, it could be a trademark name for a CRM. I'd have to see it in context. But if the originator of that standard isn't accredited, it's probably not going to be acceptable unless it's a National Metrology Institute. Anything else?
Looks like one more popped in. Is there a list of all NMIs?
There is a convention. I believe that's also out of France, like the BIPM. That's very similar, where the National Metrology Institutes, because just, and I was trying to avoid this topic because to throw more shades of gray on it. Not all National Metrology Institutes are created equal. So either you're signed on to the BIPM or another party. And the name escapes me right now because it's a French name, but they would have the list of signatory National Metrology Institutes that create standards or designated entities that do it for them. And this is important because these guys all take like high-level proficiency tests between each other. So there is a so not all NMIs can really compete at that level. So the answer is yes, but I'd have to research to find the exact web link to identify which are usable under accreditation. Yeah. Anything else?
Just a general thank you. Thank you. This is really good test for test guys that have to participate in accreditation audits and re-audits. And that's all we've got.
All right. Well, thank you everyone for your time. I hope you got something of value out of this. And I look forward to seeing you on the next webinar.